Hello, thanks for joining us. I'm Pete Zielinski, Editor-in-Chief of Additive Manufacturing Media. Welcome to today's webinar titled Moldmaking Simplified, Hybrid Metal 3D Printing for Mold Tooling, brought to you by Mantle. Mantle offers a hybrid metal 3D printing process for making injection mold tooling. It can significantly reduce lead time and cost while producing better performing inserts that incorporate conformal cooling. Nicolet Plastics is an injection molder using this tooling, and a member of their team is here to talk about that. So our two speakers are Ethan Rito, Director of Marketing at Mantle, and Eric Derner, Technical Sales and Application Engineer at Nicolet Plastics. As they speak, please ask questions. You can do that using the Q&A screen at the right of your screen, the Q&A box that it's at the right of the screen. We'll see the questions that are we will see the questions that are entered there. And at the end of the talk, we'll answer as many as we can. So I'm gonna cut out, I'll disappear, and I'll come back during Q&A. Ethan, I think we're gonna start with you. So if you're ready, take it.
Awesome, thank you for that introduction. As you mentioned, my name is Ethan Rito. Today we're gonna be talking about mold making simplified, how we're using hybrid metal 3D printing specifically for mold tooling. A quick agenda for today, we'll start by talking, or Eric will start by talking about Nicolet Plastics, give an introduction to them, talk about Nicolet Plastics and their experience with 3D printing, look at Nicolet Plastic and their relationship with tooling and how they're using tooling with their business. That's when we'll introduce Mantle and discuss how Mantle's having an impact on their business. We'll talk a lot about how Mantle works, 3D printing and its role in toolmaking in general, again, how Mantle's applications or Mantle's technology actually works. And then finally, we'll look at the impact of this. It's great to talk about how things work and what's actually possible in the printing process, but what does it actually mean for your business? We'll look at a bunch of applications, a bunch of case studies and success stories of molders and tool shops today that are using Mantle's technology. So with that, I'll turn it over to you, Eric, to talk a little bit more about Nicolet Plastics.
Okay, Nicolet Plastics basically started in 1976 as a tool shop. A lot of the customers back in that era were asking us, hey, can we sample some of your tools? Thus, 1985, Nicolet Plastics was formed. We became a really good molder over the last, 20-some years, a lot of blue chip customers. In 2017, we were bought out by a family company in Wisconsin. Holding company is Northcliffe. The family itself is owner of the Badger Mining Company. And then in 2018, we acquired CNR Plastics out of Jackson, Wisconsin. And in 2021, we've opened up a brand new facility down in Ripon, Wisconsin. A little bit about our Mountain facility. This is our low volume, high mix facility. We cover presses anywhere from 30 ton all the way to 610 ton. It's not uncommon for us to do 20 tool changes a day. We run over 300 plus resins. A lot of those resins are highly engineered resins. And this is where we do a lot of secondary operations, where we do pad printing, insert installations, machining, anything that you can think of for secondary post-molding operations for plastics. And we are a ISO 2015 certified company, and we just received our lot traceability from the UL. So our Jackson facility down in southern Wisconsin, this is going to be our high volume facility, low mix. Presses range from 50 ton to 250 ton. We're only doing a few tool changes a day. We're running mostly commodity resins. It's more of our shoot and ship, where the material goes right in the box. We tape it up and ship it out. We follow the same quality systems as we do in our Mountain facility, the ISO 9000 2015. And then this is our new facility. It's basically a blank slate. We recently moved one press in there a few weeks ago, a 390 ton. This is kind of where we're setting this up for where do our customers want to take us? Do they want clean room? Do they want a highly automated cell? And this is kind of a blank slate for expansion of our business. A little bit what I like to talk about Nicolet Plastics is, we're an extension of your engineering team. We often ask our customers, hey, when you got something that's, a model of something like that, get us involved early. We definitely want to take a look at your parts to make sure you got the correct draft. wall thicknesses, and is there any other things on the plastic, as far as features, how can we make them better? How can we make them cheaper? This is where our engineering team really excels in the business. A couple things that we do differently: every one of our parts that we tool up, we run mold flow through. We have a very extensive DFM process where once we're awarded a part, we'll go through every little detail, give you gate locations, ejector pin locations. So you're never in the dark when you get your sample product. As well, why didn't I see this stuff? Well, this is what our DFM covers. And then in 2019, this was our first adventure into additive manufacturing. We chose the carbon printer. This company based out of Redwood City, California. And no, we don't print carbon. That's the name of the printer. One of the things that why we chose this printer is this printer technology mimics injection molding pretty much to the T. The way the process is when you build the part, it's built from a liquid resin. It kind of shines a video of your part as it's building it, and then it goes into a secondary baking process which cross-links the molecules. So the build orientation really does not matter in this particular machine for strength and things that you want to do for testing. I often tell customers, if you use this process, for any of your mechanical testings and things like that, not only will it pass injection molding, but it'll be a lot superior product than what, without going through the testing phase. We really don't use this technology for high run production. We're using it to help our customers verify that their designs are right. We help them bridge the gap for some production parts before the tool is printed, things like that. It's been a really great technology for us. And, one of the things that I'd like to say is, Carbon, their own proprietary resins. They've spent a lot of time engineering these resins to make sure they work for the public. One of the new resins that just came out here over the past year was a EPX FR86. It's one of the first V0 rated resins out in the market. So. And then coming a little bit about our tool making here, we have several journeyman tool makers in-house up at our mountain facility. This is where we do a lot of repairs. We do tool making up here. This is where, we take care of your asset. And then we also have a very good supplier of domestic tool makers and offshore tool makers. So, we're not afraid to take on projects of one tool, and we've done tooling projects up to 100 tools. That's pretty common within Nicolet Plastics. Some of the challenges that we've seen with tooling, over the past few years, especially with COVID, the long lead times, the cost is going up. People are asking us, hey, can you make a tool for, 200 or less parts, and that becomes challenging just because of the cost. And then the other thing that's, they're not out there, tool makers. If you have a good one, hold on to them. And that's one of the things why we started looking at Mantle, is just because, in the future, how are we going to handle the tool making aspects of things? How are we going to compete with China? And I think Mantle brings a really great solution to some of the problems that we're all facing today in tool making. So you want to take this away, Ethan, or you want me to jump in line here?
Yeah, if you just want to jump in and talk a little bit about, what Mantle's going to allow Nicolet to do, the same challenges we were just talking about.
Yeah, the biggest thing I see with the Mantle is being able to produce a prototype tool in production time. It's pretty much all hands off. If you have the tool design already designed up, it's basically loading the model into the Mantle user interface and hitting cycle start. There's a few questions that you have to answer. And again, it's dramatically reducing the tool time and even operator mistakes. When you think about building tools, there's always that element of human error, that happens. And with the Mantle solution, it's just not there anymore. If it's modeled up correctly on the screen and it's printing, all of that risk kind of is mitigated through this process. And it also frees up our tool makers. This is going to open up a lot of capacity within the walls of Nicolet Plastics, because they're going to be able to do what they do best. And that's the magic, the final fitting of the cavity and core blocks, and all the rest of the stuff, the ants and ox that comes with, building a tool, that can be done with a lower skilled tool maker or machinist for that matter. And the guys that we have, they can continue to work on what they need to do to make us a successful tool. And Mantle is going to allow us to expand our business. It's going to level the playing field, even from an offshore supplier standpoint. We've done a couple projects already to where if we do it the Mantle way, a fully loaded tool from offshore is exactly what we'll be able to produce here now. And then some of the other benefits that we're seeing right now is the ability to put conformal cooling into these inserts, help us in the areas, even on large tools. If we have to build an insert where there's a problem area, we can quickly print that now in the Mantle and get conformal cooling up in that area of the insert, and which is going to allow faster cycle times. So it's been, the little bit that we've done with Mantle now has been really eye-opening, and they really are changing the landscape of tool making.
Awesome. Thanks, Eric, for that background on Nicolet and talking a little bit about Mantle. We're certainly going to hear from Eric again later on, talking about some specific use cases that Nicolet has seen. But from here, I'll talk a little bit about Mantle as a company, about our technology, and what really makes Mantle a little bit unique. So at a core, Mantle's goal is to accelerate how manufacturers go from product idea to launch, to really reduce the amount of time that's required to do that. And the way that we're doing this is by simplifying how steel mold tool components are made. So we're really simplifying the process that it takes for a manufacturer to produce their tool steel molding components. The way that we've done this is we've created a 3D printing solution. You're seeing the printer and the furnace on the screen here now, and I'll talk about how those work and how each one of those is unique. That delivers really, really great accuracy, surface finish, and tool steel performance that's required to produce these precision tooling components. And we'll talk about those requirements and what Mantle actually does to actually meet those. I know we've already talked a little bit about tooling, but I just want to talk a little bit about why Mantle decided to really target this injection mold tooling industry. The products that are all around you, whether you're watching this on a TV or a monitor or on a computer, or many of them are made of plastic. And for each of those products, they require tooling. For example, I'm sitting here watching this in my office chair, probably pretty similarly to most of you. Earlier today, I got down on my hands and knees and I counted how many unique plastic parts are in my chair. I counted 18 unique plastic parts. That means that this chair would require a minimum of 18 unique mold tools to produce each one of these parts. That means thousands of hours of tooling production just to make this one product. Now you imagine all the plastic products you see around you and think of all the tools that are required and all the hours that would be required to produce those tools. And as Eric was already talking about, the production of these tools comes with challenges, and these challenges are not unique to Nicolet. They're really, very seen across the entire industry. Long lead times, very, very high costs, the difficulty in finding this highly skilled labor, these tool makers that are simply just aren't around anymore and have a lot of knowledge that's required to make these tools. Another point is these tools are almost always manufactured from these relatively difficult to manufacture material, tool steels with high hardness, which makes them even more difficult to manufacture than just putting it in a CNC and machining it like you would in aluminum. So when Mantle decided that we were going to target the injection molding industry and printing of inserts, we had to kind of look at the unique needs of the tooling industry. Looking at standard metal 3D printers, it's very, very obvious that they were not designed with the tooling industry needs in mind. When it comes to accuracy, it's not uncommon for an injection mold tool to be talking tenths of a thou. So incredibly accurate tools that most printers cannot deliver that accuracy of. Durability, these tool steels that can survive hundreds of thousands, if not millions of shots at very high temperatures, high pressures, to be able to withstand, the quantities that are needed for high volume molding. Which really goes into this next point too, of known steel characteristics, tool steels, not these exotic materials that no one's ever worked with, but materials that are proven to function in these demanding environments. And of course, if you can't deliver on the speed of faster than they're doing it today, it's really going to be not overly efficient. And then of course, ease of use. We see a lot of metal 3D printing technologies that are very difficult to use. And the last thing the tool shop needs is to have another highly specialized employee that is difficult to find just to run their printer. So this is something that we saw as a very, very essential when designing and building our machine. So Mantle set out to deliver a 3D printer that was designed specifically to print injection mold tooling. We have a lot of parts we're going to talk about today, just to show you a couple, but I just want to make it very, very clear that what really sets Mantle apart is that we designed our system specifically for the needs of the injection mold tooling industry and for printing injection mold inserts. So we call our technology TrueShape technology. I'll explain how it works in a little bit, but I briefly want to talk about how we are delivering on these needs that the industry has. When it comes to surface finish, we're able to deliver a 1 to 3 micron RA surface finish, similar to a D2 surface finish, which is roughly what you'd get from a sinker EDM process. So for many applications, there's no post-processing needed for our surface finish. You can simply mold directly with it. When it comes to accuracy, we're able to hit a 1 thou per inch tolerance. So for many applications, again, that is totally within the specifications that you don't have to do much, if any, post-processing to the parts after printing is complete. When it comes to fine features, we're able to do these very, very sharp details and very, very crisp edges. I'm going to talk about what's unique about our technology that allows you to do that, but some incredibly fine features that are often requirements for mold tooling, and you're still getting those benefits of very, very flexible designs. You can see a relatively basic conformal cooling example on the screen here, but the ability to reduce cycle times and reduce part defects by incorporating conformal cooling is, of course, something that TrueShape technology delivers on. And we're printing these same stable, durable, known tool steels that the industry is familiar with working with, H13 and P2X, which is very, very similar to a P20 tool steel. So we're printing these same materials that tool shops and molders are already using today and have been proven to work in these injection molding environments. And ultimately, as I mentioned before, we've put a lot of thought into the ease of use and accessibility of our machine, that you don't have to do these things like CAM programming. It's not hard to set up. I could teach anyone on the line here how to set up a print in just an hour. So really, really easy to use, making it simple to fit into your existing workflows.
I'd just like to interject on that, Ethan, is,
Yeah,
you know, the no programming, that is really huge. When you look at a lot of these mold blocks up here, you know, you look at the countless hours of CAM programming that has to happen, especially if you've got some ribs on the core side of it. You know, not only are you programming the steel for roughing it out, now you're programming the electrode itself. I mean, all of that is gone. It's a matter of 5 or 10 questions once you have, you know, the model up in the user interface, and you're off and printing. It's just amazing technology, especially, you know, with the elimination of CAM.
Absolutely.
And I think as we go through this presentation, you know, people are going to see that, you know, that there's a cutter that's chasing, you know, the detail of what you're trying to print on the mold block. And I just want to stress that, you know, you don't need to know how to run a CAM system for this. I was out there in California when you guys first brought this out with our CEO, Tony Cavelco. And that was the first thing that just blew my mind, how easy this was to set up and print. Yeah, absolutely. Thanks for interjecting there, Eric. Totally designed in mind of, this is designed to not be a burden to run in your shop. It's designed to be super, super simple to use, that, you know, anyone could really run this. Like I said, I could train anyone on the line here in an hour to be up and running with this thing, producing inserts like I'm holding here today. Another thing that kind of goes hand in hand with ease of use and accessibility is the fact that our materials are completely compatible with traditional toolmaking operations. That means if you do need to come on and touch up some details with some EDM, or maybe do some grinding or some CNC, the part's going to be able to be post-processed in the same way as you would your traditional tool steels. No changes to standard operating procedures. You don't have to have some specialized machinist that knows how to machine 3D printed steel. You can simply put it on your machine and run it the same way you would any tool steel. When it comes to polishing, you can achieve an A2 finish. So if you do need a better surface finish on your part, that's no problem. We don't see any pitting. You're able to polish to an A2. And when it comes to texturing, chemical, deep chemical, laser etching, no problem. You can add your textures afterwards the same way you would with a traditional operation, which is super, super important, that as soon as our parts come out of our furnace, off our machine, you can hand it to your machinist, you can hand it to your tool makers, and they can work on it the same way they would any block of tool steel. And well, it's great to talk about, you know, all these features we can do and all these different tolerances we can hit. What does this actually mean for your business? Eric's going to talk a lot more about this application later on, but just an example of some H13 inserts. This was actually 3 different inserts. They were injecting a glass-filled nylon, lead time saving of 6 weeks down to 2 weeks, operating hours from 150 active tool making hours down to just 12 hours, because they were able to take it out of the printer, just do a little bit of touch up to the part and get it into the mold and start shooting parts. Like I said before, we're going to talk a lot more about this application later, but it's great to talk about specs and things like this. But what does it actually mean
for your business. It means faster parts, simplifying your process, and reducing costs. Before we get into how it works, I briefly want to have a quick poll here. I'm curious to know, what is your experience with 3D printing today? Do you have some plastic printers? Do you have metal printers? You're outsourcing. You're not doing any 3D printing, and you're looking to learn more. I'd love to just get a better toll of the audience that we have on the line here today. All right. All right. That's great to see. Oops. All right. Awesome. Thanks. Looks like we have a wide variety of kind of everything here, which is usually the case, but I'm sure talking about how Mantle works will certainly be beneficial here to understand the differences of our technology. So going into how Mantle's technology works, like I mentioned before, we call our technology True Shape technology. And it really is a complete solution, everything from materials to software to hardware. It's a complete package to go at everything from a CAD file to an insert that's nearly complete through our entire process. On the left, you can see our tool steels. I'm going to talk a lot about what makes those unique and how those are processed. But those come in a tube. It's a paste. We currently have an H13 material and a P2X, which is very similar to a P20. We already talked a little bit about the software, but automatic toolpath generation, no cam required, and our hardware, very, very easy to use, and it's designed for the shop floor. I have a couple of slides here to explain how our technology works. It is a hybrid process. It is a couple of steps, so stick with me here because it's all going to make sense in due time. Starting with our tool steels. Our tool steels actually come in a paste. That paste is similar to the consistency of a toothpaste. It's flowable, and inside of that paste is a combination of metal powder, various different particle sizes, mixed with some solvents. Those solvents allow the material to flow so it can be extruded through a nozzle. It also fully entraps all of our metal powder, so at no point are you exposed to any loose metal powder during the process, which is something when we're talking about ease of use and accessibility. Obviously, there's some barriers that come with that. So the ability to have a fully encapsulated metal powder is something that is another benefit of our paste process. So the first step in our process, this is all happening within our printer, is to print. We're printing this metal paste. It's flowable. We don't even actually have to heat it. It's viscous enough to just be extruded through a nozzle. And we're extruding this combination of metal powder mixed with these solvents. Again, no loose powder in the process. After you've printed one layer, you're going to come across and dry that layer. Here we're removing the solvent. The metal powder is actually going to settle a little bit, and you're going to the result is a high green body density. What does that mean? It means that you mostly have metal powder, tightly packed metal powder, that you have a very high density of metal powder in your part, and we've been able to remove most, if not all, of the solvent from the part at this stage. What makes Mantle really unique is we're not done just after two steps, is now we're going to come back and we're going to shape our part. If you notice when we're looking at our printer, which we're going to look at again, it looks very similar to a CNC. That's because it's actually built on a CNC body. We're leveraging that same platform. We're leveraging the same cutting tools that are used in traditional CNC machining. So after we print and dry a layer, the part has roughly the consistency of a foam. We're going to come through and clean it up, and we're going to touch up the part. It's easy to machine. We're going to improve the surface finish. We're going to add any details that weren't possible to be printed, and we're going to touch up the part and remove some material there. So print, dry, shape, that's all happening every single layer, and this process is going to repeat to build up our part. At the end of the process, we're going to end up with what's called a green part. It's mostly just metal powder held together with a little bit of binder. We're going to put that into a sintering furnace. I'm not sure how many people on the line here are familiar with press and sinter technologies or metal injection molding, but a very, very similar process where we're going to put it into a furnace. This is a batch sintering furnace. The part's going to get just below the melting temperature of the material. Any binder in the part's going to be removed. It's going to shrink just a little bit, just about 9% here, and I'll explain how we're able to achieve such a low shrinkage. And the result is going to be a 97% dense and above tool steel component. You probably can't hear it, but these are tool steel dense components that are ready to go into molding environments, very, very demanding environments. You're also getting isotropic material properties because we're doing this uniform heating and sintering process. And you're not getting any of the residual stresses that you commonly see in a laser process because we're, very, very uniformly heating and cooling our part. Because in the printing step, we are drying and removing those solvents, we have a very, very dense green body density. That means that there's not a lot of porosity in the green body, so the part does not have to shrink as much as other processes because it's already very, very dense. And of course, the lower your shrink rate, the better, because that's what allows us to control our dimensional stability so well and allows the part to come out of the furnace with that 1 thou per inch tolerance that I mentioned before. I normally hate showing videos in presentations, but I just wanted to show this one here. You can see the actual extrusion of the paste here. We're printing it layer by layer relatively quickly. It's going to then come across and dry that layer here. We're removing the solvents out of the paste. After that is complete, you roughly have the consistency of a dense foam, and we're going to come through and touch it up with our high-speed cutting tools. Variety of different cutting tools, ball end mills, etc., that we can then come in and touch up our part to refine those details on the green body. You can see just a little time lapse here. You can see some channels inside of that part as well. And the final result here is a part that's mostly metal powder. Afterwards, apologize for the animation. It's a little harder to get a camera into a high temperature furnace, but you're going to put your part into the furnace. Again, batch process, so you can put a bunch of parts in here. That furnace is going to get just below the melting temperature of the material, and you're going to go ahead and sinter into a dense, strong metal part. And as we already talked a little bit about the software, again, our TrueShape technology has a software. It's really the brains of the entire operation. Simply, you're just going to upload your CAD file. It's going to generate your additive and subtractive toolpaths in just minutes. No programming required, no CAM experience required, train users in minutes. I can't emphasize this enough, how easy our software team has made this technology to use, which is a huge advantage. And again, I never want to talk too much about features and how things work without talking about the results. And the results here are inserts that can be molded with really minimal post-processing. Here's an example from company Hypertherm. They make plasma torches of an insert. This is a slide. You can see it actually in the mold here. This is molding a 30% glass filled peak, so a very, very abrasive high temperature material. The resin was coming in at 720 degrees Fahrenheit. The tool was actually heated to 355 degrees Fahrenheit, and they didn't actually do any post-processing to the molding surfaces here. They just did a little bit of grinding to the outside as they fitted it into the tool. So you can imagine the amount of EDM work that would be required to make those feature details, and all of that was just done by the printer. So talking a little bit more about Nicolet and their success story, I'll turn it back over to Eric here, but they have a great application here that we briefly talked about earlier, but Eric's going to talk a little bit more about, the specifics of this application.
Yeah, exactly. So one of our customers, Gambert Johnson, they do a lot of docking stations for laptops, cell phones, any type of device that has a computer screen on it. And one of the challenges they have every time a manufacturer comes out with a brand new handheld device, laptop, they have to make a whole new docking station. So what this did for them is we were able to reduce, the lead time down from 6 weeks down to 2 weeks. In this particular part would normally, like again, say it would take 6 weeks. You'd have multiple, sinker EDM electrodes to take this part. And it was really, really, really a true eye-opening. And the reason why I chose this part is I really wanted to test the Mantle technology. A lot of people go out there, it's like, yeah, we're just going to make a tool. It's an open shut parting line. It's flat. This one had a stepped parting line on it, so we could really understand, the form, fit, and function of when we get these inserts back. How much time are we going to have to do secondary operations to get this to fit and get it up in our injection molding press? And I can tell you it was less than 10 hours and we were up and molding parts, so it was really eye-opening. So that really the only things we really had to do to this part, again, we had to clean up the ejector pin holes. We just blued off the shut off surfaces to see how much press that we were getting on them, a little bit of stoning here and there, touch up a little bit on the parting line, and we were making parts. It was truly an incredible thing. Again, we took our lead time down from 6 weeks down to 2 weeks. During that time of the printing, again, this is where our tool maker was, doing the mold base work, everything that had to happen, because this was a hands off. They were just sitting there. They were cleaning up all the little things that you need to do to build a tool.
Yeah,
in this particular material is a 35% glass filled material.
Yeah, and just to speak to that hands-off nature again, which, it's you're going to set this thing up in an hour, and it's going to run over the weekend. It's going to run over your holiday, etc. You're going to be sitting on the beach, and it's still going to be running. It really does run lights out, so you're able to really produce inserts with literally, hours of human interaction, which is really, I know an advantage Nicolet has seen, that a lot of our other customers have as well.
And like I said, the risk part of this, everybody's human. I started out as a tool maker, and I can probably relate to a lot of tool makers here. My scrap bin isn't the smallest either in this world, but so this really minimized that risk of scrapping out a block, because you're not touching it. It's all done, all automatic. And here's a great slide of what we got rid of. We didn't have to worry about the raw material. We didn't have to worry about the cam programming. There was no rough milling involved. We didn't have to worry about any electrodes, programming electrodes. There wasn't any finishing involved as far as the core and cavity blocks detail. This was pretty much printed, put in the tool, and molding. Yes, you can texture it, you can polish it all up, but that wasn't the specifications of this product. So it was a really unique, test for Mantle, and I'm really excited to get this machine in. I think it's slated to come in our facility here beginning of Q2, and I think we already pretty much have it loaded up with a lot of products. We've had a lot of inquiries from our customers like, hey, when are you getting this technology in house? We have some products we'd like to test this out on. So I'm really excited here in the next year to really see how fast we can fill this machine. And yes, we do have provisions. If we do fill the machine up, we'll make sure that we have capacity for our customers.
It's great to hear, Eric. So that's a great, obviously, application from Nicolet. I believe you briefly want to talk about two other success stories before we wrap up and take some Q&A. The first one being from Fathom. They're located in McHenry, Illinois. They're one of the largest on-demand digital manufacturing platforms. They do everything from CNC machining to 3D printing to injection molding. One of their subsidiaries, Nicolet Plastics, really has a state-of-the-art molding facility. They do everything from mold making to close tolerance injection molding, multi-shot tooling, bi-injected tooling, overmolding, etc. One of the applications that we worked on with Fathom was this dental guide. This is for a relatively low volume injection mold core and cavity that was being produced during the development phase here for a medical device customer. You can see the two inserts here, a bit smaller, but a lot of feature detail on here. By printing these inserts, they were able to reduce lead time by 40% and reduce the total number of operation time that was needed from 200 hours down to just 110 hours. What that 110 hours consisted of was they actually needed to still do some EDM work after printing was complete, and I'll show that in just a second. But even though they needed to do a little bit of EDM work, they reduced the amount of operation time of EDM from 100 hours down to just 27 hours. So a huge savings that was provided by printing the part to almost complete here. And then this was successfully, it was actually an overmolding application, but again, a very, very abrasive material, a 60% glass-filled nylon. And this just speaks to the value of using Mantle, even when you need to do a little bit of post-processing. You can see on the right here, the insert as printed, and then after it was burned and polished. You can see that just some of the features were too small to be printed, so they still had to come in and touch that up. But even though they were touching those features up, they still saw a 40% lead time reduction, 200 hours of operations down to 110, and removed EDM operations from 100 hours down to 27 hours. So looking at this again, what are the steps they're able to remove? We were able to remove the raw material sourcing, their CAM programming, of course, all the rough milling. They did heat treat this. This is an H13, so they heat treated up to about a 50 HRC. They did some fixturing. They had to do less electrode milling because they were doing less EDM work now. And then they just did some final EDM work and some final finishing. So from 200 hours of work down to 110 hours. The last application I want to show briefly is from Nicolet Plastics, located in New York. They are a very large-scale global contract manufacturer. They have nearly 2 million square feet of facilities. They have a very, very wide variety of capabilities, everything from product design to rapid prototyping, tool design, automation, and of course, injection molding and medical and consumer assembly as well. The evaluation we did with Nicolet was really quite unique in that they wanted to evaluate the durability of Mantle's tools. So you can see this insert that I'm holding up here. Hopefully this is coming across okay. This is actually used for molding this deodorant stick thumb wheel. Many of you are probably familiar with this, I would hope. It goes into your deodorant stick, you turn it, and it's going to advance your deodorant up through the tube it's in. They currently have a high cavity mold. There's 32 of these inserts running in it, producing millions of these parts per year. And what they wanted to evaluate was, how does Mantle's H13 and how does Mantle's P2X or P20 material compare to a traditional tool steel? So they opened up the mold, they took out 3 inserts, they printed one with Mantle's H13, they printed one with Mantle's P20, and they had one freshly machined out of S7 tool steel. Happy to say that this tool has been running for over a year now, over 1.65 million cycles and counting. It's probably even higher than that because it's opening and closing as I speak, and they've seen no signs of unexpected wear on the printed tool. So that's just to speak to, I know we talk, a lot of people think of 3D printing and they think of prototyping, but these are true tool steels. They can run in volume. And at the same time, you're still getting the benefits of these inserts were produced weeks faster than the conventionally manufactured one. So this is just a great example of, this is a true tool steel. These are designed for, like Eric said earlier, production tooling and prototyping time. I love that tagline. And this is just a single use case just to show the durability of our tool steels and a use in production. We're going to go ahead and take some questions now, but we're going to be doing a lot of webinars, obviously, and we'd love to know, what would you like to see more of? What can we do better in the future, and making sure these are useful for you, relevant for you, and would help you better understand the value that Mantle is adding. Awesome. Yeah, unsurprisingly, seeing a lot of people asking for comparisons to traditional. I hope that some of the slides we already had were useful for that, but that's definitely something we can build out more of in the future. And on our website, of course, we have lots of case studies that do that in detail. But awesome, it's always great to get some feedback on what we can talk about next time. Awesome, just give this a couple more seconds here. Awesome. Great. Yeah, it seems like really across the board, everyone's interested in everything. So I'll make sure we have great content to talk about all of these things. Thank you very much. Like I said, Eric and I now, we're happy to take a bunch of questions. Also, you can always feel free to reach out to me or Eric if you have any questions. Feel free to shoot me an email. You can even give me a call if you want. I'm always happy to talk about Mantle, always happy to talk about 3D printing. I'd love to hear about your applications. So feel free to shoot me an email if you have any specific questions that you want to talk about offline. But now we're more than happy to take some questions. Thanks.
So there's a number of audience questions that have come in while you guys were talking. First one, real simple. What materials are available?
Sure. So today we have a H13 tool steel. And we also have a P20 tool steel. In the future, we'll be expanding this into more tool steels, common tool steels in the industry. I don't want to promise anything right now, but in the near future, you're going to see some more tool steels that are highly requested from our customers coming out. And you can probably brainstorm about what some of those common tool steels are. And we're going to be continuing to add to that to really open up more applications, things like lifter heads and slides and all sorts of different applications that we're already doing, but sometimes people want different materials for.
Another question, what software is involved? Do I need someone to program this machine?
Yeah, so that's a great, I think we talked about that as well, but no, absolutely. You do not need to have any software, any CAM involved. We have a software that's going to be the entire brains of the organization, of the operation. So you don't need any software, any CAM program or anything like that. Our software is going to take care of everything for you.
Here's another question. Does the print software add the less than 9% shrink factor from the 3D data on its own, or is the designer required to add that shrink on prior to printing?
So yes, the printer, the software is going to add that percentage automatically. So all you have to do is upload your CAD file, and we're going to do all the scaling for you. I believe that the scaling is a little more in Z just because of gravity, and the part's shrinking a little bit more in Z, but we're going to add all that shrinkage factor in for you. So you just input what you want to get out of the printer, and we're going to take care of that for you.
Next question, this audience member asks, what are the dimensional tolerances of the mold tooling?
Sure. So our dimensional tolerances are 1 thou per inch, meaning it's going plus or minus 1 thou per inch, meaning it's going to scale with the size of the part. And that's because of how closely we can predict that shrinkage. So on a 2-inch part, you're going to get plus or minus 2 thou. So plus or minus 1 thou per inch. So you just have to kind of scale that with your part.
You covered this next one, but an important point worth revisiting. Is it possible to create conformal cooling channels within the mold?
Absolutely. And we see a lot of interest from our customers in doing that, especially since generally we're able to produce inserts relatively affordably and at a very quick, quickly, so that people can add conformal cooling without adding lead time and cost to an insert, which is really just going to open up the ability to do conformal cooling for many, many more applications. Because I talk to so many people who want to do conformal cooling, but then they look at the cost of doing it with traditional metal 3D printing and they say, oh, never mind. So I think that with Mantle, we're going to see conformal cooling become much, much more popular, because now you can unlock conformal cooling without adding a lot of cost or lead time to your parts.
Can this tooling be welded?
Absolutely. So we've done laser welding, TIG welding, etc. So if you need to do repair to the inserts, they can be repaired the same way you would a traditional. You can also, potentially print very complex sections and weld them to bigger sections, or use them, incorporate them into your mold to take really advantage of, Mantle, obviously, as well as most 3D printing technologies, really, really good at printing complex things. So of course, you can weld to do repair. You can weld your insert to another insert, etc., to really take advantage of the technology.
Questions keep coming. What are the size? What are the size limitations for this technology? Yeah,
so the bed size itself is going to be 8 inches by 8 inches by 6 inches, so about 200 millimeters by 200 by about 150. Roughly, that's the max size, but as parts get larger, they do get a bit more challenging because you're trying to control shrink across a very, very large part. So we're seeing really our target size being more in the 5-inch by 5-inch by 5-inch size and smaller. Today, we have done parts that are larger than that, but just and another thing that we see a lot of people doing is putting multiple parts on this same build, right? So you put a core and cavity together, they're going to run over a couple of days, and then you have both your core and cavity printing at the same time. So the max build size is 8 by 8 by 6, but we like to see parts more in the kind of 5-inch range.
I love this next question. I know this is an issue with some metal 3D printing systems. The question says, can builds be saved with a power outage interrupting the build?
Yeah, so I've spent, lucky to spend my whole career actually in metal 3D printing. And this is one of the coolest things I think about Mantle, is that actually when parts are being printed, if you were to have a power outage, which surprisingly happens, you can actually just machine back your part and start printing again. You can machine back to a known height, to a known layer number, and just remove that material and start building on a flat surface again. So absolutely, if power goes out, you're able to save your build.
Do parts experience warpage during sintering?
So they can, and that's one of the burdens of sintering, and one thing that you're attempting to mitigate. But one thing I will say is that the fact that we're able to remove our solvents and binder during the print process, and our shrink rate is so low, we see significantly less warping and moving of parts in the furnace than other additive technologies, because we're able to control our shrinkage so closely, and that we don't have a lot of binder that we're removing during the sintering process. So I'm not going to say parts never warp. Of course, there are situations where that's going to happen, and we have design guides to help with that. But we have a very, very controlled shrinkage, because what we're sintering is mostly just metal powder. We don't have to remove those binders.
This is what really intrigued Nicolet Plastics, was, the ability to print this without having a lot of induced stresses involved. I mean, you think about it from a thermal stress relieving. When the block comes out of the oven, all the detail is done. You get stresses added into the block even when you're machining normal tool steel. you're done with all those stresses after it comes out of the oven. So it's a really unique process. We found that the blocks to be really, really stable.
Another question, can one printer easily switch back and forth between H13 and P2X?
Absolutely. So the material comes in these tubes. They're very, very easy to install on the outside. And like I mentioned, to stop being heated, simply pump through a tube into the extruder nozzle. You're simply just going to have to obviously swap that tube, and you're going to do a little bit of purging and cleaning your tip, or even simply just replace your tip. They're not overly expensive to ensure there's no cross-contamination. So just, in a couple, 30, 40 minutes, pretty easy to swap your material over.
You covered this, but let's hit it again since the question came in. What is the XYZ size of inserts you can print?
Yeah, so the max size of the build on the printer, so this is the physical limit, would be 8 by 8 by 6 inches. And we certainly are experimenting with some things at that size, but it becomes challenging when parts get big because as they shrink, you're moving a lot of mass. So our ideal, kind of size limit, or what we'd recommend, is more in the 5 by 5 and smaller, 5 by 5, and then depending on the height, inches.
More questions coming. Does either Mantle or Nicolet build custom tooling for customers who can't afford to buy a machine or want to try it out? Or can you recommend a custom tool shop that uses it?
So I'll say that Mantle, today we sell equipment. We certainly do not want to compete with our customers like Nicolet or our other customers. So we sell equipment. And Eric, I'll let you take it. Are you looking to work with people?
Yeah, absolutely. We're going to be, that's the whole point of this, right? We're looking to partner with not only our customers, but other tool shops. So, if you're looking for an insert or something like that and you can't afford the machine, we're definitely going to be open to helping the tool industry print their own inserts and things like that. So, my contact information is up on the screen. Once we get the printer up in our facility up and running, feel free to reach out with questions or comments or things that you need, and I'll help you out with it.
What is the smallest end mill size supported by the machine?
Yeah, sure. So this is something that's obviously evolving as we're continuing to do process work. Today, the smallest end mill we have is a 10 thou ball. So that allows us to leave a 5 thou radius. And we're, I'll just go ahead and say this, currently we're going to have a 6 thou ball coming very soon as well. So we're using standard cutting tools, things that you can buy, off the shelf. Obviously we have specialized cutting speeds and things like that. So kind of there's no ceiling to what we're able to do with cutting tools. So today, 10 thou, soon 6 thou, and the world is kind of our oyster here. We'll see what comes next. And that's really driven by, as I'm sure Eric will say, we're really driven by our customer demands. What our customer says they want, what they need, that's what we're going to develop. Because what's so great about Mantle is that since we're so focused on this application, if one customer is asking for one thing, that's going to apply to the next customer as well. So all the innovation we make really has a direct impact to all of our customers.
Can you reprint on the printed part, like in the case of an engineering change?
Yeah, so unfortunately, since the part does go through a sintering process, you're not able to print on an existing metal part, right? Because it then has to go into the furnace. It has to be heated and it's going to shrink. So you're not able to print on an existing part, but you can weld it. So if you want to, you could print a section and then weld it back onto a component, but you're not able to print on an existing metal part.
I guess someone on the West Coast would like to see this live. The question is, will you have a system up and running at MD&M, the Medical Design and Manufacturing Show in California?
Yeah, so sadly, we won't have a printer there or a furnace. We're working on getting all those out into the field to our customers who are patiently waiting for them. But we will have lots of parts. We will be there, booth 3995, and we're always happy to host anyone at our facility in San Francisco if you're ever in town or want to come out. We'd be more than happy to show you our equipment in person and show you around. But I really encourage you, if you are at MD&M, come by the booth and check out some parts because it really makes a difference. It doesn't really come across on the screen. I bet you Eric can speak to this as well. When you pick up these parts and you feel, the tool steel and you feel the surface finish and you look at the feature detail, it really, I've seen tool makers who haven't been impressed by anything in 40 years, jaws drop. So it really does. The parts speak for themselves. So if you do have the chance to see us at a show or want to come out and see us, please do.
So this question gets down to numbers and specifics. Says,
all right, I'll do my best.
what's the price range for a machine? What's your current delivery? And how do I get an in-person demo?
Sure. I would say for pricing, we're very, very comparable to a high-end CNC equipment. I don't want to talk specific pricing on the line just because my sales team might get mad at me, but feel free to email me and I'm more than happy to talk specific printing. And I think you can find it online too. In terms of deliverability, we're currently taking orders for shipping in the Q2 and on range. And if you want a demo, feel free to email me or Eric. We certainly do evaluations. That's one thing I'll offer to everyone here on the line. One thing, obviously, we're going to work with you to prove out a use case, to prove out an ROI. If you want to send us tools, we're happy to generate slides on what would it cost to print? How long would it take? Is it a good idea to print it in general? Can we print this, or do we think it's not a good idea? We're happy to do that evaluation for you. If those numbers are looking good, we're happy to actually print parts for you as well to help you with your evaluation. So I'll say that for anyone on the line here, if you're looking for a demo, feel free to reach out to me, and we'd love to set up some time to hear about your application and to hear how Mantle could potentially add value to what you're doing today. So please feel free to email me if you have any questions or are interested in the demo.
Ethan, this next one's a callback to the example you gave. The question says, of the 18 unique molded parts on your chair, how many could not have inserts prepared by a Mantle printer due to dimensional limitations?
That's a good question. I'm sure some of the larger, bars and things like this that are on here are a little bit outside of our size limit, but I would say at least half of them could be. There was, the knobs, the smaller complex parts, the wheels, some of the covers and things like that could certainly be made. The other thing I'll say is, just because a part is larger than our insert size does not mean that Mantle can't add value. We see a lot of tools, specifically automotive tools that are huge, right? But there's made up of hundreds of different parts, right? There's slides, there's inserts, there's lifter heads, things like that all benefit from Mantle as well, and can also be benefited from conformal cooling. We see that a lot where there's one kind of trouble spot on the tool, so they go ahead and print a section for that tool on Mantle with conformal cooling, and now we're able to mitigate that risk. So, commonly we talk all the time about, when can you do bigger? We want to do huge parts. Think about, there's lots of things that currently fit into our size range that still add value, whether it's a whole insert or just a part of the mold you're working on today.
Is this technology solely for plastics injection molding, or have you tried it for metal injection molding?
Yeah, that's a great question. Certainly, a lot of the requirements are very, very similar when it comes to metal injection molding. We are trialing a bunch of metal injection molding products with various customers because they have the same challenges that the plastic injection molding industry has, right? Tool making is difficult, long lead times, high costs. So certainly looking at NIM and powdered metal applications as well. So if you're interested in that, we'd love to explore that more with you as well.
Is the same material used for low volume and high volume inserts?
Yeah, so that's the great thing about our technology is that the same material can be used if you want a prototype or production. It's not going to change your cost. It's not going to change the processing time. We actually see almost all of our customers interested in the H13 material over the P20, simply because they were only using P20 because it was easy to machine and relatively inexpensive. So they go, all right, well, if I'm going to be able to just choose, they're going to cost the same price, might as well go with the 42 HRC H13 because I get that added hardness, extra strength, and it's not going to cost me anything extra. So we are using the same materials for whether you want to prototype a part or do production. Like Eric said earlier, I love this. I'm going to keep saying this tagline over and over again: production, tooling, and prototyping time. So we're using the same materials.
This question asks, setting aside the lead time advantage and the benefits of that, how would just the cost of a finished printed tool compare to a conventional tool?
Yeah, sure. So very willing to look at cost models for you. A part like this, for example, this is an insert for a handle, for a medical handle. This is going to cost you about $400 in just material. A fully burdened cost is going to be maybe closer to $1,000 to $1,200. Of course, it's going to be very, very application dependent. We really see the most value added when we can eliminate or reduce EDM time. Parts that require a lot of extensive EDM get very, very expensive very, very quickly. You can imagine the amount of work that would be needed to produce all these ribs. So this is an example where almost every shop we've talked to that has been able to quote this, we've seen a reduction in cost via Mantle. So again, we're more than happy to quote out parts for you, to have you send over your parts just to ship. We can run cost models for you, etc. But something like this is about $400 to $500 worth of material, a fully burdened cost, including power, labor, machine depreciation, etc. It's going to be closer to $1,200.
If I can interject here,
Sure.
Ethan, some of the stuff that we've seen and some of the costing that we've done with this is, for a full tool, it's equivalent to a fully loaded tool made offshore. By the time you add your tax tariffs and air freight, what do you want in there? It's really leveling the playing field to have an American-made tool at overseas prices.
Yeah, I love to hear that, because that's really what the goal is. And it's a really unique time for the industry, as I'm sure many of you in the industry know. A lot of people are trying to bring tooling back to the U.S. But as Eric said, and a lot of people say, you can't just hire more tool makers. You got to look at technology and ways to scale your manufacturing without scaling labor. And Mantle is the technology that's allowing you to do that.
When your parts are textured, how does the acid time compare to traditional materials?
Yeah, so as far as I know, it was identical. No changes to standard operating procedures. They were able to follow the same procedures that they would for a traditional P20 or traditional H13, and they were able to, the same amount of time. It's one great experiment. We see a lot of our, we say that and people don't always believe us. So a lot of people, when they're evaluating our technology, will send them a block of steel, just a generic test sample that we're printing for us, whatever reason. And they hand it to their machinist. They go, hey, do you mind grinding this and cutting, a little notch here and maybe weld it back up for me? I just want to see something. And then the machinist comes back the next day and goes, oh, here you go. And he goes, anything weird? They go, no, it's H13. They can't even tell that it's been printed, which is really the goal of what we're trying to establish, is that no changes to standard operating procedures, very, very easy to process. And you can just, it's going to fit right into your existing workflows.
Yeah, we actually played that trick on our tool maker here at Nicolet. We got the block in and gave it to him. And I said, just do what you normally do with it. And he came back and gave it to me. And I said, this started off as basically toothpaste. He's like, what? I go, yeah. And I showed him the video at Mantle, and it's like, oh my God, this is really eye-opening.
I see one audience member is asking if this webinar will be available offline to view, share. So yeah, all the audience members are going to receive an email with a link to a recording. That'll come soon. Another question, how are the blocks removed from the machine once the process is complete? And does it need to be ground?
Yeah, so that's another thing. If you're familiar with laser-based systems, you'll know, when printing's done, it's welded to that build plate, right? So you have to either do some wire EDM, you have to keep your bandsaws around, do a lot of post-processing. And if you're lucky, it comes off easily. If you're unlucky, the whole thing moves after it comes off the build plate. For us, the part's going to lift right off the build plate after printing is complete. It's attached just to the build plate, adhesively, so you can just really pop it right off, and it goes into the furnace onto a ceramic tray. So you don't have to do any crazy processing to remove a part from the build plate. In terms of, does the part need to be ground? Totally depends on the application. We see a lot of people just do a little bit of spotting stock, and they come out and they touch it up really, really quickly just to make sure it fits perfectly into the insert. But really, really depends on the application, of course. And I know, Eric, that your application that you showed, just a little bit of grinding, right, to get it into the tool.
Yeah, there wasn't much to that. It was truly, very easy secondary operation work to get this thing up and running and molding.
We're coming up close to the top of the hour, but we have a few more questions, so we'll probably go right to the end.
And again, if we don't get to everything or your question's not answered, please feel free to email me. I'm more than happy to take more questions offline and get you the answers you need. So if we run out of time, I didn't get to your question, feel free to just shoot me an email.
Where are the Mantle machines manufactured? What's the warranty?
Yeah, so our machines are manufactured in San Francisco, where we currently are building a bunch of them right now. We have a pretty extensive print farm that's turning out parts for both development as well for people who are doing evaluations. In terms of warranty, I know we have a warranty, but I don't want to say the wrong thing. So shoot me an email and I'll get you our full warranty information, just because I want to make sure you get the right information.
Does the machine have tool change capabilities?
Yeah, so we are built on an existing robo drill style CNC with a FANUC controller. We kind of take all the difficulty and use out of it though with our software, so it's very, very easy to use. And there are 20 tool slots on that machine. Today we're utilizing, I believe, 10 of them. but we're able to, it has automatic tool changing. So it's going to automatically select the best tool for the job, whether it's a 3/8 end mill or it's that 6-thou ball that I was telling you about earlier. It's going to automatically do that tool pathing and all the tool changing automatically as well. So it's really a set it and forget it machine.
And I think this might be the last question.
Sure.
Do sintered parts have a martensite microstructure?
That's a good question, and that's another one that I'll get back to you on. I want to double check with my material science team to make sure I don't give you the wrong answer there. But feel free to shoot me an email there, and would love to get you an answer.
All right. So clearly, some people very knowledgeable about mold making and mold tooling who are watching this with interest. Yeah.
Yeah, it's great. I love to talk to the additive manufacturing crowd. I'm definitely an AM junkie. I'm also now a tooling junkie and a molding junkie. So feel free to shoot me an email or give me a call. I'm always happy to chat about your applications and all the cool stuff we're doing at Mantle.
All right, this was great. We'll call it there. That concludes today's webinar. I want to thank our presenters, Ethan Rito of Mantle and Eric Durner of Nicolet Plastics. Guys, thank you so much.
Thank you.
Awesome. Thanks.
Learn more at mantle3d.com and at nicoletplastics.com. As we mentioned earlier, an email with a link to a recording of this webinar should come to you soon. Thank you for your time today. I'm Pete Zielinski with Additive Manufacturing Media.